Alright folks, today we're working on correcting 41 to 43, the last three problems of our mock EOC. So we'll start with 41. The chart shows the number of students by gender in each grade at a local high school. The principal will randomly select one student to meet the governor. So, probability is always given by a total divided by what you want, your desired outcome. So, let's figure out what this stuff's asking. Let A equal choosing a female, so probability, and B choosing a ninth grader. So B is a ninth grader, but they have to be female. So our total is just going to be the total number of females in the entire building. And our desired outcome is we want just the ninth grade ones, the ninth grade females. So our total number of females in the building comes from 80 plus 95 plus 75 plus 80. Gives us 330 total. Our desired outcome is just the ninth grade ones. So we look in the ninth grade column, there are 80 females. So the probability of ninth grade female is 80 over 330. We have two zeros here, so to reduce, we're going to divide each of them by 10, which gives us 8 over 33, which is answer D. Okay, let's look at number 42. Iman starts with $1 on day 1 and then doubles her money every day thereafter. On which day will she first have more than $10,000? So this is a thing we'll actually talk about more of in 10.1, which is called sequences. We can kind of figure this out by ourselves. So on day 1, she's got $1, right? On day 2, we just multiply that by 2, we have $2. On day 3, multiply it by 2, we've got $4. And we'll keep continuing. Day 4 is going to give us $8. Day 5 is $16. Day 6 is $32. 7 is 64 bucks. 8 is 128. 9 is 128 times 2, which is 256. 10 is 512. 11 is 1024. 12 is 2048. I don't know that one off the top of my head. 2048 times 2 is 4,096 times 2 again, 8,192. 15 is, let's see, times 2 again, 16,384. Okay, so they're asking the question, on which day will she first have more than $10,000? 15, 14, 10, or 6. So 6, she's got 32. Nope. 10, she's got 512. Nope. 14, she doesn't have more than 10,000. So it has to be A, because on day 15, she has more than $10,000. Okay, last EOC correction. This table shows some terms of an arithmetic sequence. The sum of the first n terms is 2,464. What is the nth? We're going to use adding and subtracting.
So they're giving us some gaps here. We've got a gap of 1, 2, 3 things and a gap of 2 things. So in our gap of 2, we go up 8 units. In our gap of 3, 31 minus 19, we go up 12 units. So if we have to go up twice in here and 3 times in here, divide this one by 3 or divide this one by 2, we're going to get a gap of 4 every single time. So as we have 31 goes to 35, we can work backwards to 27, to 23, 19 minus 4 is 15. Okay, so they're asking for what is the nth term. So I don't totally know how to do this unless you use some quadratics. But you could plug and chug. So let's do, by the way, this is 10.2 called series. Yes, it says sequences, but when you add them up, if you sum them, it's going to be a series. So we've got a couple of formulas we're going to use. The first one, S sub n equals n over 2 times a sub 1 plus a sub n.
And the key to the right side of that formula page where I got this from is just on that formula page, which is right here. I got this from right here. It told us that S sub n is the sum of the first n terms. So it didn't even give us the exact wording. It tells us n is the number of term. A sub n is the nth term. So A sub 1 is the first term. A sub n is whatever next. This stands for usually the last term. So when we go back and look at this one, we're told the sum of the terms, we're told that is 2,464 equals, we don't know the n number of terms, so let's leave that as n over 2. We do know the first term, a sub 1 is 15, and let's try to figure out what would happen if we just use this formula to figure out the n if 62 was that last term. If 62 was the one that when we use it and we added all of them up, then we had 62 as our number if we got 2,464. So we're going to put in 62 right there. So 15 plus 62 is 77. Divided by 2, take care of this division. So we're going to have 2464 equals 38.5 n. Divide both sides by 38.5. So to give us 64 equals our number of terms. So let's plug that into the other formula which we're going to use today, which is the formula for the arithmetic sequence one, which is just right here. So a sub n equals a sub 1 plus n minus 1 times d. And if it works out, we get an equation where both sides are equal. So if we use this n and let's see here, our last term. So our a sub n equals a sub 1 plus n minus 1 times d. We know our common difference of 4. We know our n should be 64. Our first term is 15. And we said our a sub n, we're going to try it and see if we get 62 as a result. So if both sides here are equal, then 62 is our answer. If they're not, we're going to go back and try another one. So 15 plus 64 minus 1 is 63 times 4 is going to be 267. 62 doesn't equal 267, so D is not the answer. Let's try the next smallest number, 139. So do the same thing. So 2464 equals n over 2, 15 plus 139. So we're going to get 2464 equals, okay, so 15 plus 139 is 154. Divide by 2 to take care of this division. We get 77n. So to get n by itself, we're going to divide in both sides. 2464 divided by 77 is 32. So that says it's the 32nd term if we use 139. So let's plug it into our other equation, see if it makes a true statement. So we're going to say 139 is our number, equals our first number of 15 plus, we're thinking this is the 32nd term minus 1 times our common denominator. So 139 equals, let's see, 15 plus 32 minus 1 is 30. Okay, it works in
both of these equations, so 139 has to be your answer. And if this seems a little complicated right now, that's okay. You guys haven't gotten to 10.2 yet. We will get there, it'll make more sense. Okay, folks, this is it. If you need to correct any other ones, put this away, take it home with you this weekend, and do it this weekend. This is due on Monday. If you have already finished correcting all the rest of them, though, turn it into me. We're going to